Now we're on topic 6.3, which is fuel types and uses. So you can think about this lesson as sort of, I'm going to be talking about like biomass. So this is kind of like an extension on what I've talked about before on biomass. And it's sort of like an introduction to fossil fuels. So how do you get, specific fossil fuels in the first place, and what they're used for. So this whole page is about biomass. Now, just to review, biomass is a subsistence fuel, meaning that it's used for, just meeting your basic needs like cooking and heating. And it's very easy to get, which is why less developed countries use it. So, you can kind of think about like caveman back then. And in order to cook their food, well, it's very easy to get, a couple of sticks and some wood chips and then just, create a fire. And that's how they cook their food, or, that's how they heat themselves. All right. Now, charcoal is also a biomass fuel. So, believe it or not, charcoal isn't actually coal. It's just going to be heated wood under low oxygen. So, wood's going to be heated under low oxygen conditions, and that's how you get charcoal. And charcoal is going to be mainly carbon and ash. So it's going to be mainly made up of carbon and ash. Now, you also got peat. Peat, this is like kind of step one to creating coal. So first of all, what's going to happen is you're going to get decayed plant material that just accumulates and accumulates, and this is going to happen in acidic and oxygen poor environments like bogs and swamps. So you have acidic environments, you have anaerobic conditions, meaning low oxygen conditions, and decayed plant material. Got all three of those factors, that's how you form peat. Now I said how peat is actually a biomass fuel. All right, peat isn't actually coal, but peat is kind of the precursor to coal. And this is kind of like an in-depth guide of how peat turns into coal. So what's going to happen is pressure from rocks and soil, they're going to compact this peat more and more, and the more pressure there is, or the more energy dense this peat's going to become. So I've actually ordered this, so there's kind of like a couple steps to this, but I've ordered kind of all of these steps in order of time and energy density. Now, all three of these things you'll see here are coal. So this right over here is lignite, this is bituminous, and this is anthracite. And they're all different types of coal. First of all, peat's going to turn into lignite, all right? And then after a very long time, then it's going to turn into bituminous, and then after a very long time. Now, the thing to know is that, well, lignite is actually, it's not as energy dense as the other two types of coal. Lignite is the least energy dense out of all of these types of coal, all right? And anthracite is the most energy dense, all right? So it has the most energy per unit of mass out of all of these types of coal. So that the thing about anthracite, though, is that it's pretty rare because I've ordered this from time and energy density, and anthracite, as you can see, takes the longest to form. So even though it's the most energy dense, it takes the longest to form. So this is why, mainly people use bituminous, because it's more common and it still has a decent amount. Now, how is coal actually used for energy? So, the first step you got to do with coal is you got to mine it, right? That's going to be like kind of the obvious first step. But then how do you so if there's 5 important things I have to take away from this entire unit 6 apes, well, this is one of the things that, that would be in my top 5. So how do you create energy with coal? Well, what's going to happen is you're going to burn this coal. So it's going to be in these little chunks, right? And you're going to burn this coal. And what's going to happen is it's going to release a lot of energy, right? And this energy is going to heat this water, which turns into steam. The water spins a turbine. Turbine powers a generator, and then this generator generates electricity that, this is onto a power line, so it's probably going to be distributed to, people living in buildings. So this process is very important to remember because literally, you can do the same process. You do the same process with wind energy. So in the case of wind energy, what happens is you have the wind spinning like those giant wind turbines, and that powers a generator, which generates electricity, right? You can have hydroelectric dams. So hydroelectric energy comes from the movement of water. So if you ever seen one of those big dams near like the water, basically it's taking the energy from the movement of the water and this is converting into electricity. Well, guess how that goes? You're taking the movement from the water, which spins a turbine, which powers a generator, which generates electricity. Same for nuclear energy. You're letting the uranium react, and this is going to steam the water, which spins a turbine, and blah, blah, blah. So if there's one thing to take away from this unit, or, one of my top 5 things to take away from this unit is, this process where, you're using the steam to, I don't want to say it again. Now, here's how natural gas and crude oil, also known as petroleum, this is how they're formed. Natural gas and crude oil, they're the 2 main types of fossil fuels. You also have coal, which we discussed before. So this is kind of the other 2 fossil fuels that we haven't discussed and how they form. All right. So first of all, you're going to have, this is going to be in the ocean. So let's say this is the ocean. Now, at the bottom of the ocean, you're going to have dead marine plants. You're going to have animals that are decaying because they died. Now, under increased temperatures and pressure, this organic material, right over here, is going to turn into hydrocarbons. Depending on like the temperature that, it experiences, well, it's either going to turn into crude oil or natural gas. Crude oil is formed under lower temperatures and natural gas is formed under higher temperatures. Over millions of years, what's going to happen is there's going to be just layers and layers of rock, right? Layers of rock, and then this gas is going to be trapped inside the rock as well as the oil. And now, because, the gas, it's going to be less dense than the oil, so it's going to be trapped higher above the rock compared to the oil. So this is kind of like a diagram to show y'all kind of what happens after like a very long time. So at the top right over here, you're going to have a bunch of sediment. And then below the sediment, you're going to have an impermeable layer of rock. Impermeable just means that, it doesn't really allow liquids, things like water to pass through it easily. So think about this. Think about the impermeable layer of rock as sort of like a wall that blocks this natural gas from escaping. So then where the natural gas and where the oil is, you're going to have this porous and sedimentary rock. All right. And this type of rock is usually called shale. So this is also called shale. And below the shale, you're also going to have an impermeable layer below the oil and the gas. And this layer of rock right over here prevents this oil from escaping. All right, so the way I like to remember this is it's sort of like a sandwich, right? You can't let the natural gas escape. You're going to have this impermeable layer of rock above it. Can't let the oil escape down there, right? It's going to be blocked somehow. So you're going to have this impermeable layer below the oil and the gas. Let's talk about how to extract the crude oil. So in order to extract crude oil, what's going to happen is have this thing that drills a well all the way down to where the oil is, and it's just going to be pumped back up. All right, just drill a well, pump it back up. However, there's actually another way to extract crude oil. Now, originally, right, we saw how, over millions of years, right, you saw how this dead organic matter turned into crude oil. However, things like bacteria and groundwater can interact with this crude oil. And what sort of happens is it actually turns into something known as bitumen. So bitumen is basically the thick version of crude oil. So, crude oil doesn't have to be always in kind of this form. It can also be in the form of bitumen. All right, and notice how it's actually closer to the surface. So that's something important to keep in mind. It's going to be this bitumen's this thick, tar-like substance. All right. Now, the problem with just drilling a well down here and sucking this bitumen back up is that it's very sticky. It's going to be too thick to suck back up.
What? Bro, what are you talking about, man?
Imagine drinking, for example, a smoothie, right? And you're using a straw. It's going to be easy to suck the smoothie up. But imagine trying to, use a straw to drink syrup, right? That's basically going to be kind of impossible, right? So it's a little too sticky to suck it back up. So what's going to happen is we're going to heat this up with steam, all right? And so this well right over here is going to be with steam. And what's going to happen is it's going to kind of melt the bitumen so that it's less thick. And now that it's less thick, then you can suck it up with this well. Now in later lessons, we're going to kind of cover kind of the cons of this, because obviously, you know, extracting all of this stuff, it has a lot of consequences to the environment. After you get the crude oil, what can you use the crude oil for? Well, crude oil actually contains a lot of something known as hydrocarbons, which are just compounds that only contain carbon and hydrogen. So some examples of things that are in crude oil are methane, ethane, and propane. Now the thing about crude oil is that crude oil itself is pretty useless. But when you put it through a process called fractional distillation, this is when it becomes useful. Basically, crude oil, we said how it's made out of all of these different compounds. And all of these different compounds have a different boiling point. So you can actually separate these compounds based on their boiling point, and you can create a lot of products. So bitumen itself is actually, you can actually use bitumen itself for things like asphalt. So, the thing you see on roads, you notice how you have all these different types of kind of oils that you can use for transportation. Here's how to extract natural gas. So natural gas, you're going to do a process called fracking to extract natural gas. Once again, you're going to dig a well down, but then what you're going to do is you're going to dig this well kind of horizontally. So you're going to go vertical, then horizontal. And you're going to inject something known as fracking fluid, which is just mostly water, propane, acids, detergents, right? You're going to inject this down here. What it's going to do is it's going to fracture the rock a bit, because keep in mind that we're going to be injecting this fluid at very high pressures. So at very high pressures, this rock is going to sort of fracture a bit. And when the rocks fracture, well, notice how it's going to release all of the natural gas, all of this natural gas that, is stored in the rocks. So, natural gas is going to be coming up, and as well as, the fracking fluid. All right, so the fracking fluid is going to come down, but eventually, it's going to have to come back up, right, with the natural gas. Now here I want to highlight the fossil fuel emission levels. So this basically shows you kind of how much of each pollutant does every sort of fossil fuel release. So we have natural gas, we have oil, and we have coal, and we're kind of looking at how much of each pollutant does it release. And I just want to highlight that natural gas is definitely by far the cleanest energy source. It does not release as much carbon dioxide. Actually, it doesn't release, basically, compared to the other two fuels, it basically releases, not as much compared to all of them, except for carbon monoxide when you compare it to oil. But other than that, all of the stats are lower than oil and coal, which is why natural gas is considered to be the cleanest energy, source when you're talking about fossil fuels. Now, I just want to talk about, what all of these pollutants do. So this is also going to be sort of an introduction on, the pollutants you got to know for APES. So you got carbon dioxide, which is a greenhouse gas, so it contributes to global warming, right? And that's a lesson on its own. Carbon monoxide is a highly toxic gas. So you can't see the gas, so it's invisible, and you can't smell the gas. So you only know that you got carbon monoxide poisoning when you're dead. All right. So that's the reason why, in your house, you probably have a carbon monoxide detector. Is because, you don't know if carbon monoxide's in your home until you actually, feel the symptoms of it, which is, poisoning, dizziness. It can even lead to death. So very, very deadly. Then you have nitrogen oxides. It causes respiratory issues like asthma. So, it just worsens your lungs. Sulfur dioxide, same thing, irritates your lungs as well. Then you have particulate matter. Particulate matter, this just refers to kind of tiny solid or liquid particles in the air. And once again, this also causes lung damage. And finally, you have mercury, which is, this is on the periodic table. This is a very toxic and heavy metal. And this can damage nervous systems. And it's especially dangerous to children.